Hello everyone. In this video, we will learn about the deadlock prevention. In this topic, we are going to learn about the set of methods for ensuring that at least one of the necessary conditions cannot hold. First one, mutual exclusion. It's not required for shareable resource. For example, read-only files, a number of processes could share it at a time. But mutual exclusion should hold for non-shareable resources. For example, mutex lock. Hold and wait. It must guarantee that whenever a process is requesting a resource, it should not hold any other resource. That is, each process should make a request for a resource and be allocated all its resources before its execution. So before it begins the execution, it has to be provided with all the set of resources it wants, or allows a process to request resources only when the process has none. There are some disadvantages of the above two protocols. That is, it suffers from low resource utilization and starvation is also possible. For the hold and wait, it must guarantee that whenever a process requests a resource, it does not hold any other resources. Here we are going to learn the two protocols with examples. The first method, it requires each process to request and allocate it with all the resources before it begins execution. That is, a process, if it wants to copy a data from a DVD drive to a file on disk, sorts the file and then prints the results to a printer. Here, the process should make a request and be allocated with all the three resources here. But the printer is required only at the end, but the process will be holding it for the entire execution. That's a drawback here. In the second protocol, where we are allowing a process to request resources only when the process has none, this allows the process to request initially only the DVD drive and the disk file. So it's copying from the DVD drive to the disk and then releases both the DVD drive and the disk file. The process must then request the disk file and the printer. After copying the disk file to the printer, it releases the resources and it terminates. This is how the protocols will work. No preemption. If a process is holding some resource and is requesting for another resource that cannot be immediately allocated to it, then all resources that are currently being held are released. Preempted resources are added to the list of resources for which the process is waiting. The process will be restarted only when it can regain its old resources as well as the new ones that it is requesting. No preemption. Let us see how it works. How can we prevent the deadlock for this condition? Here, if a process is requesting a resource, we need to check whether it is available. If it is available, we can allocate it to the process. In case if they are allocated to some other process that is waiting for additional resources, we can preempt the desired resource from the waiting process and allocate them to the requesting process. Suppose if they are not available and they are not allocated to other process, this else condition works. The requesting process must wait. While waiting, some of its resources may be preempted if another process is requesting them. So, a process is restarted only when it is allocated the new resources it is requesting and recovers any resources that were preempted. Circular wait. Here, a total ordering of all resource types is followed and it requires that each process is requesting the resources in an increasing order of enumeration. That is, let this R1, R2, Rm be the set of resources. We need to go for a one-to-one function. That is, f is a function and R is the resource, where R is assigned a number, where n is the set of natural numbers. For example, This f of tape drive is 1, f of disk drive is equal to 5, f of printer is equal to 12. So this is a one-to-one function. So the first protocol tells if the process can initially request any number of instances of resource type, say Ri, then the process can request instances of Rj if and only if f of Rj is greater than f of Ri, which means this Rj represents the resource that P is requesting for, and this Ra is one which is this initially it requested for. So this f of Rj should be greater than f of Ri. The second protocol. Alternatively, whenever a process is requesting an instance of resource type Rj, it has released any Ri such that f of Ri is greater than or equal to f of Rj. If these two protocols are used, then the circular wait condition cannot hold. In this video, we have learnt about the deadlock prevention. Thank you.